We spent the last couple days graphing cosine. Today we're going to be adding sine to the mix now. So you're going to be graphing sine today. And again, we start by taking a look at that table of values. So our points that we saw when we did cosine. So I break out my trigonometric values table. And remember, we figured out when we did the cosine that we needed those decimals. So that's how we got the root 2 over 2 and the root 3 over 2. And so what I'd like you to do then is, since this is the same basic idea as cosine, where we're just going to take these points, like 0, 0, 30, and 0.5, and so on, and plot them on our graphing grid, please go ahead and just start and plot those points. Here's the points that you should be looking at for 0 to 90 degrees to make sure that you're off on the right foot. Alright, and then once you've plotted the rest of the points that are actually appearing in our table, this is what you'd be looking at for individual points. Now, this has a familiar feel to it at this point, I hope. If I draw the curve in that goes through those points, and yes, we need to plot all those points so we can know that it's exactly this kind of a shape, then we draw our curve through and we can see that this is a similar looking wave to what we saw with cosine. Now, having done this part of the graph, that is graphing the part from our table down here, I need to continue on. And remember how we continued with the cosine graph. I was thinking of those coterminal angles. So like, I'm next going to go over to this point, which is at 390 degrees, because 30 plus 360 gives me a coterminal angle. That is an angle that's at the exact same place at the circle, and therefore has the exact same sine value. And so at 390 degrees, it's going to give me the exact same sine value. I go to 390 and 1/2. And so basically because of that is we're repeating the table. So we're just repeating it through now, these angles here. So if you haven't yet done so, please plot the rest of the points out to 720 degrees. And then when you've plotted all those other points, repeating the same thing through, and then draw the curve through those points, this is what your whole graph should be looking like. So make sure that's looking good. And one little side note here, you notice that it is just repeating that same pattern. I do want to point out that on the left side, if I kept going, it'd be going down over here, left of 0. Because it's still following the same wave. And I mention that only because sometimes people think of it as actually reflecting it over. And so they actually think, okay, then it's going to be reflected across the axis. But that's not what it does. It just continues the same wave, doing the exact same thing as the others have been. All right? So now that you can see the graph of sine, how does this graph compare to the graph of cosine? Yeah, so one thing is the starting point changed, right? So sine all of a sudden is starting in the middle, but cosine was starting at the top. So that changed. What else might have changed? Not much there, right? We don't really seem to see much else that's changed because a lot of other stuff is the same. Like, look at what is the same here. How tall is the wave? It's going like from -1 to 1, or 0 to 1 if you're measuring like from the middle. And that's true for both of them. The height of the wave is the same. How about the width of the wave? Well, it can be a little bit trickier to check because we got to count right. But like if I look from, like, let's say top to top. Well, top to top here with sine goes 90 to 450. That's 360 degrees wide. If we do the same thing with cosine, that goes top to top, just the top is here at 0, and then the next top is at 360. It's also 360 degrees wide. They have the same width. In fact, basically everything about these is almost the same. If we stack them up next to each other and see what they look like here, you can see how sine really is the same graph as cosine. It's just like it's been moved over. But that's the only difference. It's kind of like I took all of the points from my cosine graph and I just took them all and moved them to the right by like 90 degrees. And so it really is the same graph. So we started just with cosine, but the fact that you can graph cosine means you can now graph sine as well. The only difference that you have to remember, though, again, where does it start? Sine starts in the middle, cosine starts at the top. And if you can remember that, you're going to be in good shape. Some quick notes. Go ahead and write these down because we keep having to talk about how tall the wave is. We need to be specific with our vocabulary and make sure everybody has this. That amplitude specifically is that distance from the midline to the top or bottom of it. And by periodic function here, all it means, that just means a function that repeats itself, like sine and cosine do. Now that we've seen how sine ends up looking, we're going to go ahead and make use of some of those graphing grids you've got down there on your paper. So go ahead and write down this equation above your first empty graphing grid. All right, so in this case, we're graphing y equals 2 sine theta minus 1. Remember, theta here works just like x does. It's just the Greek letter theta. And so if I'm going to make this graph, I have a change in my amplitude and I have a change in my midline. Because of that, I actually want to draw the lines onto my graph, those dotted lines that I've talked some about, because it's going to make life a lot easier. So whatever is added or subtracted onto the end, that is our midline. That's the very first thing I draw. So since it's a minus 1, I'm going to put a dotted line across down at negative 1. And then the amplitude. That's the 2. Amplitude tells me, again, that distance from the midline to the top or the bottom of the graph. By the way, amplitude, because it is a vertical distance, distances are always positive, so if you're ever asked, like, what's the amplitude of this function, it's always positive. All right, so our amplitude here is 2. That means from my midline that I drew earlier, I draw a dotted line that's 2 above it, and I draw a dotted line that is 2 below it. By drawing those in first, I now don't have to remember the 2 and the negative 1. Now I'm just focusing on graphing sine of theta. And where does sine start? The top, the middle, or the bottom?
Top.
Sine starts in the middle.
Just kidding.
Cosine starts at the top, but sine starts in the middle. So I put my first point there at 0, actually on that middle line. So I put it on the midline. Remember, I drew those in so I didn't have to think about how high up it is. I just looked for the middle one. And then when we graphed sine earlier, you saw from the middle it went where? Did it go up or did it go down? It went up. And so my next point then at 90 must be at the top. And again, just like with cosine, I can generally get away with just plotting the points at 90-degree intervals. If you want to plot other points in between, like the 1/2 or something like that, you can. But I'm not going to. But it can help you be a little bit accurate if you're having trouble getting the curves to look good. All right, so I just started at the middle. I went to the top. Well, I remember my pattern: middle, top, middle, bottom, middle. Notice in that pattern, basically you're just bouncing between top and bottom. And if you're ever going between the top and the bottom like this, well, you have to pass through the middle. Then once you have all your points plotted, then you go ahead and you draw your curve that goes through those points. It can take a little bit of practice to get this curve coming out looking good. Everybody's got their own techniques. When I do these on paper, I tend to use very light pencil strokes at first, and I'll often turn my paper to a comfortable direction so that I can get the curve to actually come out looking like I want it to. Different people are going to do it different ways though. So find a way that works for you to get your sketch of the curve to look pretty good. Because we're looking for a wave here, not a lightning bolt. All right? All right, and when doing this graph, again, there's quite a bit going on in the equation. So I'm going to be drawing in the midline and the top and bottom lines again, just so I can kind of keep track of that. So the midline, again, that's whatever is added or subtracted onto the end here. And so my midline is the +2. So I'm going to put a horizontal line here, dotted, up at 2. I always use a dotted line because if it's solid, I'm saying this is part of my graph. A dotted line is saying this is just a guide. It's not actually part of the graph itself. All right, now the amplitude though, the amplitude comes from the number in front of sine. That is what we multiply by. What's the amplitude in this case though? Well, we can know it because, well, we just see negative sign, but really that's like a -1 sign. But the amplitude itself, remember amplitude has to be positive because the distance. So it's actually, the amplitude is actually 1. So if you're asked for what's the amplitude, you'd say 1. Whereas my midline here was at 2. So that means that for my top and bottom lines, I'm going to go 1 above my midline, and I'm going to go 1 below my midline. Having drawn those in, I've dealt with the +2, and I know where the top, the middle, and the bottom are. But I still got a couple things I need to deal with. I still have the negative that I'll be dealing with here in a moment, and I have the -90 that I'll be dealing with. Now the -90 means that I'm going to put my very first point right 90. So my first point that's normally in the middle, instead of it being over here at 0, it's going to be over here at 90. Now the negative does not change that point because it's in the middle. Anything that's on the midline, a negative doesn't change that. It's still on the midline. What the negative does change is where we go from there. Because the negative out front of any function, remember, flips it upside down. And so that means that from the middle here, instead of going up, I'm actually going to go down. And so my next point is at the bottom. And once I've plotted those, I can actually plot all the rest of the points because I now know where I am in the pattern. I went middle, bottom. So middle, bottom, middle, top. That same pattern for cosine works with sine. And you can pick up in that pattern anywhere within the pattern, including going from right to left. So middle, I'm sorry, that's not middle. We start at the top at the far right, top, middle, bottom, middle, top. And so then I can know as I go to the left then that that next point must be at the top. Now that I've drawn in those points, I can go ahead and draw the curve that goes through them. And so then this is what you should be looking at with your final graph. One thing that's a bit interesting when we take a look at this graph, if you were just looking at this graph and you didn't know what equation gave it to you, you'd probably be thinking it was a cosine function, right? Because it's starting at the top over here. And that's one of the things you'll find is oftentimes sine and cosine graphs will look a lot like each other. It's just any shifts that we make left or right will make it look like one or the other, but you can still use either one. In fact, for every single sine equation, you could write a cosine equation that would look just like it, or vice versa.